Excellent. Okay, good. All right. Tonight's program, just to give a quick snapshot, Mr. Boyle will do his usual duties on Ottawa skies, letting us know what's up, what's down. Al Scott's going to give us the astronomy news update, what's new and exciting in the world of astronomy and space research. Jonathan is going to give us a summary on a rather interesting report that was released just recently on the state of Canadian science and technology. As many of you are probably aware, Canada is a leader in quite a number of fields in science and technology, and this report actually does a pretty good job on summarizing some of our advances, some of the things that we've been noted for worldwide. So looking forward to hearing Jonathan's summary. He's going to be focusing on the astronomy part of that. Tony Peterson. Tony Peterson's got something special for us. I'm not going to steal any of his thunder. Granite telescope piers. I'll let your minds think on that one. After Tony's presentation, we'll take a bit of a break, have a stretch. We'll do our door prizes, and then we have observations. Believe it or not, there's some. Yeah, we haven't had a lot of great skies in the last couple of months, but we do have some, including a summary afterwards from John Thompson on his Australian solar eclipse adventure. And then I'm going to do something on winter imaging in the Great White North. So that's what we've got on tap. What do we got? Oh, we have no members in the news this month. So without further ado, here's Gary.
Thank you, sir. Thank you.
You're welcome.
Good evening, everyone, and Happy New Year. Sorry I couldn't make it last month, but my wife was really sick, so I had to stay home with her. So on to the next slide, or the first slide. Of course, we're still dealing with the winter sky. We all know where Orion is, but we're going to focus on Auriga, the charioteer. It's a very prominent constellation. We have, of course, Capella, the extremely bright star, about first or second magnitude. Next slide. So we'll deal with the three main open clusters. In fact, it's really a target which you don't even need a telescope, just binoculars to really enjoy, especially one of the major open clusters. But still, a telescope will work on a nice wide-angle scope. So we can see that Capella, 42 light years, just some distances. So at least when you look, you know how far away it is. So pretty well, most of us, when we were born, is light when Capella left. Next slide. Well, most of us. Okay, I was 14 years after that. Okay. Yeah, M37. It's one of my favorite clusters. It's a very dense cluster, and a lot of the stars are the same magnitude pretty well. So they're all pretty well the same brightness. Usually, when you come to open the clusters, you'll get one or two bright stars, but here it's pretty well the same. Of course, with a photo, you see many more, but live is really something else. And it's for 4,400 light years, and it's just naked eye visibility. Next slide, please. Okay, next we have M38 on the very end, along with NGC 1907. You can see they're almost just over 4,000 light years, but it's almost like a beautiful double cluster. A couple of hundred stars in M38 and a lot less in NGC 1907, but in binoculars again, or wide-angle scope. And it's pretty well about 35 arc minutes across, so it's pretty well the width of the full moon. But if you're able to actually take a wide-angle image of the entire area, you'd get the next slide, which I did not do. M38, but next slide will actually give the labels. Next slide. 38, the ones that we just looked at, along with a beautiful IC for 417, which is a combination of an emission and reflection nebula. Actually, sorry, this guy, emission and reflection. M36 and M37 be about over here. So a lot of nice wide open stuff in this area. Beautiful, wisp of nebulosity up here. Next slide. So Pan-STARRS is trekking on through. It's still in the teens of magnitude. It was first 19th magnitude when it was discovered on June the 6th, 2011 by Pan-STARRS in Hawaii, but is still through Corona Australis, which you'll see a chart in a few moments. but slowly it's going to be moving up and will grace our skies starting around the 10th, the 8th of March. But after that, it really boots going up after that. A little more next month, but still prepare for this guy. The initial estimates were like 0 magnitude, but now they're bringing it down to maybe 3rd magnitude. So it still should be a very nice naked eye object. And in fact, on the 12th, you're going to have a very small crescent moon, less than 2% crescent moon will be in the field. But we know the cloud conditions will be, or the biggest snowstorm of the year will be on that day. But then moving up toward Cassiopeia, it'll start to really diminish in size. It'll shrink to about 1 magnitude every 5 days or every 5 nights. So once it leaves the perihelion, it really gets dim and moves very fast. So do your work around here if you can. And it's going to go right through, like I said, through Cassiopeia.
What's the night of projected peak magnitude?
Well, the peak night, actually, it around the sun on the 7th and just around new moon. So for the first week, as you can see too, the moon is here. But actually, the peak is on the 7th or 8th.
But Gary, it won't be visible on the 7th. It'll be only during the day.
It's just on the horizon, yeah.
It's not till the 12th that it's you're going to get a
Yeah, we're just,
glimpse of it before
yeah,
it
for
sets.
here, yeah, and it'll be like a
13th
half degree or something like that on the horizon.
Really close to the horizon.
But night after night, it's going to get a little higher, but then again, a little dimmer. So, potato. Next slide, to give the entire how it's really going to move fast. So we're actually here now, February 1st, around the 12th when it's closest, the 10th, where we're actually going to see it above the horizon here, and then after it really boots on. So it'll be favorable for northern observers, and should be, they're stating, the brightest comet since the 1990s, since Comet Hale-Bopp and Yakutaki. Not that Kahutak stuff. Let's hope not. Next slide. And on the night of February 14th, Valentine's night, we're going to see that the 4 Galilean moons are nicely lined up along with Jupiter. So that's a nice photographic moment if you can, if you have a wide angle, well, pretty wide angle scope. It's almost binoculars or a telephoto lens for this one. So again, Valentine's night, if you don't have any plans with your sweetie. Next slide. Saturn is starting to rise early in the morning, about 5 a.m. It'll rise around 3, but to make it a nice pictorial moment over here, another digital moment will be actually on the 3rd, 2 nights from tonight, with Spica and Antares. And you can see that the summer constellations are slowly coming up. You wouldn't tell by temperatures, except for yesterday morning when it was really, really nice and warm. And next slide. And of course, the moon is a favorite for anyone. This is my granddaughter, Abby. She's 2.5, looking at the moon this morning through her make-believe telescope, which is a paper towel core. So she's following in my footsteps, just like Gord with his daughter. So we'll be seeing her up on the stage in a few months from now. So it takes out her, there's no eyepiece in there at all. She just looks through it. Well, actually puts it right here. It doesn't put it over her eye. But still, she was pointing right at it, which was great this morning. And 30 seconds later, I'm cold, and that was it. So I was able to snap one picture with the iPhone. And next slide. And just a rundown of your favorite planet, if you do have one. Who has a favorite planet over here? Nobody? Come on, no one's got to have a favorite. Earth. Great. And the next slide, of course, with the lunar phases and distances. Lunation 1,115. And thanks to the Farmer's Almanac, the full moon will be the snow moon. I don't know why they took February for snow moon. We have snow since from November almost. So. And that's about it. And so we'll see you next month. And the great news is I finally sold my house. I'm moving to South Mountain in 19 days. Country skies, so I can't wait. Can't wait. Take care.
Is anybody going to attempt to observe the asteroid close approach on the 15th?
Oh,
3.5 Earth radii.
yeah, but I think that's actually on the other side of the Earth.
It is actually on the other side of the Earth. By the time it's visible for us, it will have dropped quite a bit in brightness and be moving a lot slower.
3 p.m. our time, I think, is
Yeah.
20 hours UT
Yeah.
is the closest. And it's really moving too, like one lunar diameter per minute or something like that.
Yeah, I think it's it's twice, 2 or 3 times the moon's diameter in a minute.
Yeah.
When at its closest. So yeah, booting along.
So I don't think we'll see it, but Someone out there, well, I'm sure on the other side, Gary.
Cool.
For our chance, no.
Well, thanks, Gary. And you know, the little one there, when she gets a bit bigger, you know, when she outgrows the paper towel, maybe you can give her the sonotube that you're using now. You know, just a thought.
Can I borrow yours first?
Good one. All right, Al Scott is going to give us his astronomy news update. Al, take her away.
Thanks, Paul. So, first item up, planet formation. So astronomers using the Atacama Large Millimeter Submillimeter Array, which I've spoken to you about before, the ALMA telescope array, have seen a key stage in the birth of giant planets for the first time. Vast streams of gas are flowing across a gap in the disk of material around a young star. These are the first direct observations of such streams, which are expected to be created by giant planets guzzling the gas as they grow. Astronomers studied the young star named HD 142527, which is over 450 light years from Earth, and it's still surrounded by the disk of gas and dust from which it was formed. The remains of the cloud are there, and it's divided actually into an inner and outer ring by a gap. The gap is thought to have been carved by newly forming gas giant planets, clearing out their orbits as they circle the star. Now, based on the distance and the angular diameter of this, we can tell that the inner disk reaches from the star out to about the equivalent of the orbit of Saturn in our solar system, while the outer disk begins about 14 times further out, or about roughly the place where the Voyager spacecraft is right now. The outer disk doesn't surround the star uniformly, but instead it seems to have a bit of a horseshoe shape, so probably caused by the gravitational effect of orbiting giant planets. According to the theory of the planet formation, the giant planets grow by capturing gas from the outer disk in streams that form bridges across the gap in the disk. And so you can see on the left is the actual observation, and on the right is an artist's impression of what astronomers think is actually going on. The disk in the gas in the outer disk, sorry, the dust in the outer disk is shown in red. Dense gas in the streams flowing across the gap, as well as in the outer disk, are shown in green. Diffuse gas in the central gap is shown in blue. The gas filaments can be seen at the 3 o'clock and 10 o'clock positions flowing from the outer disk towards the center. The dense gas is actually being observed. They're looking at a particular line emission of an HCO molecule, a carboxyl ion, and the diffuse gas is actually carbon monoxide observations. The outer disk is roughly 2 light days across. The observations answer another question about the disk around the star. As the central star is still forming and growing by capturing material from the inner disk, because there's a gap, it should have used up all the inner disk material. But the fact is that the planets, by streaming gas from the outer disk into the inner disk, continue to feed the star and help it to grow larger. So an interesting observation, and you can see how the precision of the measurements helps to feed the theory and move forward on our understanding of how these planets are being formed. The next one, I'm going to show you some adaptive optics images from Gemini. This is from the Gemini Altair adaptive optics system in the year 2007, which was state-of-the-art at that point. It uses a laser guide star which is projected up in the sky to measure the turbulence along that line of sight and subtract it out of the image to get sharper image than you can from the atmospheric seeing. If you're an astronomer, you know that this turbulence in the atmosphere disturbs the stars and blurs them. Typically, the seeing that you can achieve is between or on the order of 1 arc second in really clear skies. The next one is I'm going to show you is a picture from the Gemini, the new multi-conjugate adaptive optics system, which uses 5 guide stars which are spread out across the sky instead of just one. And it actually uses medical tomography to make a pattern, to understand a pattern of turbulence throughout the atmosphere in 3 dimensions, model that, and remove those from the star distortions to provide a sharp image across a much larger field. This is actually 85 arc seconds across. The seeing at the time of this picture, atmospheric seeing, was on the order of 1 arc second. The resolution of the image, though, is 10 times better than that. 0.08 to 0.1 arc seconds. It took 10 years to develop the instrument that was able to do this. What you're seeing is a portion of Orion. The colors are 3 filters, each taken 600 seconds of integration. Blue is iron 2. Orange is hydrogen molecule. And white is a K-band continuum filter of 2 microns. In this image, the blue spots are actually clouds of gaseous iron bullets being propelled at supersonic speeds from a region of massive star formation outside of the picture and from this field of view. As these bullets pass through neutral hydrogen gas, it heats up the hydrogen and produces glowing pillars that trace the passage of the iron clouds. These were actually discovered in 1983, and they're called the Orion bullets. They're clumps of gas ejected from deep within the Orion Nebula, located some 1,500 light years from our solar system. The violence causing this is likely related to the recent formation of a cluster of massive stars with strong winds that can expel gas at supersonic speeds through the nebula. The bullets that you see here are actually quite large, each of them about 10 times the size of Pluto's orbit around the Sun. As the bullets speed outward, they leave distinctive tubular and cone-shaped wakes which shine like tracers due to the bullet's heating of the molecular hydrogen gas. The wakes span much greater distance than the bullets, measuring as much as 1/5 of a light year in length. Now, an interesting thing is Chris is actually going to be able to flick back and forth, and you can see from the 2007 image to the 2012 image how much these bullets have moved. That's 1,500 light years away, so they're moving pretty fast. And you can see how much larger this image is compared to the single guide star and how much it's corrected all the way out to the edges, whereas the other one is corrected mainly around the central guide star.
So Al, are the bullets like concentrated clouds of iron atoms? Or we're not talking like any kind of a solid matter?
No, they're gas. Yeah, iron
So it's
iron
like
ions.
Yeah, so it's
They're
like,
ionized iron.
that's ion cloud?
Yeah. Yeah. Now, I'm not sure if there's probably other gases there too, but they're looking at the iron line specifically here, so these have extra iron in them. Okay, thanks.
Well, thanks, Al. I don't think I'd want to be in the way of one of those things. All right, next up we have Jonathan, who is going to give us a summary of the state of science and technology in Canada. Jonathan.
Just a little lead into what Al was saying. You notice that new discovery used the Gemini telescope. Canada had very significant contribution to that telescope. And it's interesting, in fact, it's my privilege to bring a congratulatory message to the people of Canada and also to groups like this, the Royal Astronomical Society, in making a small country like Canada one of the world leaders in all kinds of science and technology. And this may come as a surprise to you. In fact, I was recently talking to a diplomat from Ecuador, a country down in South America, about the size of Canada, and he was saying, he says, you know, Canada's an amazing country. 35 million people. You are small. You're a small country. And yet you have a tremendous influence on the world. Now, we know politically we do, but scientifically we do too. Now, here is the cover published just recently by a nonprofit organization funded mainly by the government, a group that not too many people know about, the Council of Canadian Academies, which is really a group of a series of experts from across the country and from different parts of the world who were contacted by the Canadian government to do a survey of the things that Canada is good at in science and technology. Because the government wants to know this, because with all the billions of dollars they throw around, they would like to spend some time in researching what this country is good at before they spend their money. In fact, just before they make the wrong decision. But in this case, it's a winner. And so they contracted this group to do a survey, and they came out with this rather thick book. That, by the way, is the only picture, a very good picture, I think, in fact, that describes the state of science and technology in Canada. And they found out that Canada was 1, 2, or 3 in a whole series of scientific and medical fields. And one of the main ones is astronomy, astrophysics. And you wonder, how did this happen? How many clear days does Canada get to look at the stars? And yet we are one of the world leaders, in fact, number 1 in many areas. Now, this group used experts from across Canada. This was not just a survey done by, school students. They used experts to survey the effect of Canadian technology around the world. Now, Chris, if you can show that video.
The Council of Canadian Academies is a not-for-profit organization that produces independent, authoritative, evidence-based assessments written by experts on issues in the public interest. Their latest report, The State of Science and Technology in Canada 2012, is an in-depth analysis of the scientific disciplines and technological applications where Canada excels worldwide. As Canadians, we have contributed to vital advancements in aviation, medicine, engineering, telecommunications, and many other fields. An 18-member expert panel assembled by the Council of Canadian Academies has developed a comprehensive report on the state of science and technology in Canada. It's one of the most in-depth examinations of Canadian science and technology ever taken. The panel conducted its assessment by using a balanced combination of measurement techniques and new research methodologies. Using this approach, the panel concluded that Canadian science and technology is healthy and growing. The panel found there are 6 areas of research in which Canada excels. They are clinical medicine, historical studies, information and communication technologies, physics and astronomy, psychology and cognitive sciences, and visual and performing arts. The diversity of these fields demonstrates the breadth of Canadian research strength. This strength is spread out across the country. Ontario, Quebec, British Columbia, and Alberta are the powerhouses of Canadian science and technology. Between them, they produce 97% of Canadian peer-reviewed papers. They also have the best performance in patent-related measures and the highest per capita numbers of doctoral graduates. The panel found Canada's smaller provinces are developing areas of specialization, such as agriculture, fisheries and forestry, historical studies, earth and environmental sciences, and biology. The report includes a survey of the top-cited 1% of international researchers. More than 5,000 responded, revealing that Canadian science and technology is highly regarded throughout the world. 37% identified Canada as one of the 5 leading countries in their field, placing Canada 4th behind the US, UK, and Germany. In terms of international collaboration, Canada is working with the most scientifically advanced countries in the world. Top researchers are coming to work, and students from all over the world are coming to study. In fact, Between 2005 and 2009, Canada had the highest rate of growth in doctoral graduates among selected OECD countries. Looking ahead, Canada is well placed to become a global leader in a number of emerging areas, including wireless technologies and networking, information processing and computation, and digital media technologies. In addition, Canada is building research strength in nanotechnologies, personalized medicine and healthcare, energy technologies, and tissue engineering. Canadians have much to be proud of. Science and technology is robust from coast to coast. Our population is highly educated, and internationally, we're well respected as a country with world-leading research infrastructure and programs. The Council's report provides a snapshot in time of a dynamic, rapidly evolving, and highly competitive environment. The State of Science and Technology in Canada 2012 is one report in a new series of assessments by the Council. Each report addresses a different aspect of Canadian science, technology, and innovation. To learn more about the expert panel's report, visit scienceadvice.ca.
Thank you. Yes, if you'd like to get a copy of this, it's available from their Slater Street address. One of the executives told me that it costs them $50 a copy to make this information available. You can get it free from their office. But here are some amazing facts. One of the areas that they said that Canada is a world leader in is in astronomy and astrophysics and cosmology. And their ratings that they found, we are number one in the world in research papers in physics and astronomy, and also nuclear and particle physics, especially as it relates to astrophysics. Also, they rate us number two in the world in, let's see here, general physics, physics and astronomy, and also in other areas involved in telescopes and other fields. So, considering we're 35 million people in a world of 7 billion, this is truly an amazing accomplishment. In fact, I've had personal experience in just how important Canada is. I don't know how many of you can remember years ago when the Avro Arrow was canceled. I'm old enough, I can remember when it was canceled. And I can remember that day in Toronto. In fact, it was a couple of days later. There was an engineer working for Avro at the time there. He was a member of a Bible study group that I was involved in. And I asked him about it, and he was furious. He was angry, not because he lost his job, but because, as he said, how stupid is the Canadian government? Don't they understand that this aircraft is the most advanced technological plane in the world? The Russians and the Americans don't have the equivalent of this plane. So I asked him, well, are you worried? What are you going to do now? Worried, he says. Are you kidding? He says, American headhunters are swarming the plant right now, grabbing as many Canadians as they can to go down to the United States. He says, what about you? He says, yeah, I've been recruited for the American space program. I said, please, can you take me with you? You know, I haven't seen him since, but you can be sure he's done very well. And you consider, with all the brain drain, Canada has been a supplier to the world, not only of information, but imagine all the brains that have left this country over the last 100 years. And remember, this club here is 100 years old. So groups like the Royal Astronomical Society should be congratulated because you have fostered this kind of public awareness of the importance of science and technology, and it's been one of the major reasons for our great prosperity that we have had in the last 100 years. Another incident just recent, well, not just recently, but my wife and I were fortunate to take that, and thinking of this kind of weather too, taking that Caribbean cruise back in 1998 to see the total solar eclipse. And we didn't know it, but the ship that we had picked for the Caribbean cruise was the same one that the Calgary Royal Astronomical Society group was also on. And I was quite thrilled that that ship was just full of astronomers and scientists and engineers. And the Canadian group, as my wife said, hey, we're the most knowledgeable people around here. And I remember going down for breakfast one day, and this handsome couple came up and sat right in front of me, across from me at the table. And the husband had a T-shirt. He was wearing a T-shirt, and in big letters on the T-shirt it said, "Actually, I am a rocket scientist." Well, I tried to contain myself. I didn't want to giggle too much, but I smiled and looked over at his wife and said to her, "Did you buy him that T-shirt, or is he really a rocket scientist?" And she said, "Both." So we got into a terrific discussion. I asked him, yes, he's working for NASA, and he said he was working for the Clementine Project. He was a scientist on the Clementine Project. And I said, oh yes, that's the one you're looking for water on the moon. Well, he was astonished. He said, you know what, in this whole ship, you're the only one that knows what the Clementine mission was all about. He said, I'm quite amazed, and you're a Canadian. And he says, and you know about it. But the Canadians were very prominent in there. In fact, when we woke up on eclipse morning, it was raining and cloudy. And thank God the captain got on in a couple of hours and said, folks, he said, don't despair. He says, we have some experts here with us who know the satellite imagery of the area. We have identified a clear part of the ocean. The ship has turned, and we're headed toward that area now, and everything turned out perfectly. It was a wonderful trip. So there you go. Down through the years, we have been really blessed as a nation with this science and technology. It's really marvelous to think that we have had this great privilege. In fact, just yesterday, talking about tooting our horn, I have this newsletter that comes to me from the Middle East, from the state of Israel, and here this newsletter says, right on the headline, report, Israel is the second most educated country in the world. That's right, another expert panel said that Israel was the second most educated country in the world. I said, well, isn't that fine that they have such a respect for education? Guess who was number one? Us. Canada is recognized by the, let's see, what is it, the OECD, in fact, the OECD, as the most educated country in the world. And that's based on percentage of citizens who have attained to some post-secondary education. Truly, this is an amazing country. So, just in conclusion, I would like to join with the Council of Canadian Academies to congratulate Canada and to congratulate groups like yourselves in having achieved this marvelous state of affairs where Canada is in such a leading position. So you've deserved your well done. Thank you.
Well, thank you, Jonathan. Look forward to reading that report, actually. All right, Tony. Tony has a surprise for us.
Well, hopefully this is.
I'll leave it to you. Go ahead.
That was really inspiring. I can assure you that Canada is also a world leader in geology, very much so. And what Jonathan just told us reminded me of a story that I heard from one of my colleagues years ago who had brought a visiting science from India. And as he was coming up the steps to our office building, he paused and stopped. And the fellow who brought him said, "Why have you stopped here?" And he said, "I just have to relish this moment. I'm about to walk up the steps of 601 Booth Street, which is the address that's on all these fantastic papers that I've been reading for so many years. So this is really a great country. And you're about to hear of a gift from your government." I pushed the wrong button. It's
Right
going to be
way.
this one. Good, okay. Many of you may be surprised to know that,
Stand near the mic.
yeah, that your government maintains a rock collection. But it doesn't really look like this. It looks more like this. Tray after tray and row upon row in a warehouse facility at Tunney's pasture. Not something that would interest us very much here. But wait, what is this thing at the back there? It looks like a large polished cylinder of beautiful rock that might form an admirable telescope here. In fact, that's what it is. Are there any more of those? Yes, there are. This material has been sitting on the floor at Tunney's pasture collecting dust for the last 10 to 15 years and is in danger of being thrown out. And due to the efforts of our current collections manager, who is Ann Terrio, and did Ann make it here yet? No, she can't make it. I was hoping she could stand up and take a bow, but she has young kids and wasn't sure if she could make it here. Anyway, she's been fighting the bureaucracy, because of course there is a bureaucracy even for garbage. And she has managed to get most of this material in a state where it could be donated to the RASC. And I wish I didn't have a concrete pier in my backyard because I'd love to use one. So I'll just quickly, I don't want to spend a lot of time going over this material. I'll just show you a few of the things that are here. There are a lot of these square, solid rock, polished bases. These could be used underneath a short stone column, or you could mount a steel pier on these. You just have to bolt it to it. Something that's a bit more portable than bolting a steel pier to a concrete platform in your backyard. There are several of these. There's one, that one's granite. This looks like a, well, diorite. Another polished granite right there. I just left my glove and everything for scale. Some larger ones here that would need a shorter steel column on top. There are also several slabs that are tall enough on their own to mount a telescope onto. 3 like that. There's one more of those black ones. There's a large square granite one. There are several round ones. This one here is hollow, and it looks like you could mount some hardware to that quite easily as it is. There are 4 particularly beautiful ones, which the curator is a little bit leery of letting us have because they are quite beautiful and fairly valuable, and she's concerned that they would just end up in somebody's backyard and not be seen. Paul and I have agreed this one here, which is the best of them all, has perfect dimensions, is absolutely beautiful, should probably go onto the SmartScope site. And Anne has agreed to that. That's the top of it right there. It's perfect dimensions for a telescope here. There are 3 others which are much larger. There's a beautiful granite one there. This is the biggest of all. That is a monster. It weighs about a ton. It's some kind of a green gneiss. And I'm not sure if I have photographs of the other ones. No, oh, you put the sheet up there. Okay. So I have to recuse myself from being involved at all in distributing these. We're not really sure how much interest there would be there out here amongst members. Gary, you just moved. You must want to set up a pier in your backyard. Which one do you want?
Number 9.
Number 9.
Yeah, that's the big one.
This one. That's number. Yeah, nope. Sorry. Yeah, that's going to the SmartScope site. I'm not sure. We would have to. I have to talk very nicely to Anne about getting these very large ones released to individuals. I think probably we can talk her into that, because if they're not used, what will happen to them? They'll get thrown out. I don't know.
Is there any history to them?
There probably is. I don't know what it is right now. These were initially actually collected from, I guess, construction sites by Richard Hurd. Anybody here who knows about, is interested in meteorites knows Richard Hurd. He's retired now, but he was the former curator. So he's the one that got all these together. So I will help as much as I can with arranging people who are really interested, coming and seeing them, pulling up in a truck and taking one out. If I was to use one of these, I would want to drill holes in the top, put bolts in so I can mount my hardware onto it. something like this would have to be sunken into the ground a little bit, I think, because it's just too tall as it is. But that's just a fantastic resource for anybody who wants to have a very solid setup in their backyard, which doesn't look hideous like a concrete pier does. So I don't know if Paul wants to.
Yeah, I just had a quick question for you, Tony. Is there any possibility of getting holes drilled like that using the facilities at where they are now?
We don't have the facilities for doing drilling in anything this large. Well, actually, some of the shorter ones, the granite
Block?
bases, the blocks, yes, we could drill holes into those. I think probably a better solution might be if we got organized about this, to just get some company in someday and drill them all in the parking lot in the back, do something like that.
Right.
That would be the most efficient thing. What I would really like is to have all this material, if we could beg some storage room from the museum here, is to have this material moved here so people could actually come and see it. It's a little bit awkward for me to take individuals to Tunney's pasture, but I can do that and I'm willing to do it. And if you want to arrange yourself for to, bring a truck and take something away, you have to have the equipment to do it. But
Great.
anyhow, so there you go.
Any questions for Tony at all on that? I'll do a little bit of a follow-up, but any questions?
I'll just stand off the side here in case.
Well, as you can see from the images, there's some really nice stonework there, and if you were to pay to have something like that done, we're talking big bucks. So I think this is a wonderful opportunity, and it would certainly break my heart to see any of that stuff wind up in a landfill somewhere, especially since I think I've already paid for part of it. Chances are. So anyway, we've got a list there. We can make this available to anybody that's interested. If you are interested, please send me an email, okay? Because what we want to do before we say, yes, you can have that, I'd like to gauge the level of interest that are in these stones, so that if there's a lot of interest, maybe we'll have to do a raffle or something like that. If there's only a bit of interest, then perhaps you can get your pick of the item. We still have to discuss things like the logistics of moving these things. I can certainly follow up with the folks here at the museum to see if we could perhaps get that material away from NRCan, because then it's like out of sight, out of mind, and then they won't worry about trying to dispose of it. It's already gone, right? So if we can perhaps get some space here where, as Tony mentioned, we could members could easily have a look at these things, that certainly might make things easier.
One thing I could do is take better pictures, and perhaps on the website or somewhere, anyway, we could post the pictures on the dimensions, and then people can get a better idea.
Okay.
Well, you could just take the average density of a rock and work it out yourself from the dimensions.
Yeah.
They have been measured.
They're heavy. Yeah, you're not going to throw this in the back of your
But that's what you
Volkswagen.
want for a telescope. It's got to be something which is.
It's gotta be
really
solid.
heavy, Really, really solid, yeah.
So in terms of actually physically moving them, I mean, if we can get them on site here, we'll have to see if we can arrange that somehow. But getting them from here or from where they are now to your own site, that's something we'll have to investigate. Certainly, there's going to be a bit of shipping charge, let's say, because these things are massive. They're certainly not even a 2-person lift. I would think most of them they're more like a 5-person lift, or better still, a forklift. So yeah, there is some logistics. There will be some cost involved, but if you're at all interested, as Tony mentioned, I'm hoping to get one of the nicer ones there as a pedestal for the Smart Scope. I'll be talking to you about Smart Scope shortly, but once we have that project up and running, I think a pillar like that would make a nice finishing touch for it to honor all the people that have put a lot of time and effort into it.
I had one question, Paul. Did you actually want one of those for the Smart Scope itself, or something that's on the grounds outside the building?
Something for outside, to put a plaque on. Yeah, not for the Smart Scope itself. It's already on a massive pillar, not anywhere near that pretty, but certainly fairly large. So, Yeah, sundial.
See,
There's
that's what Ann wants to avoid. She doesn't want people to say, it's really nice, and,
Okay, so don't say sundial.
yeah, you're putting a bird bath on top.
Yeah, no bird baths either. So yes, please, what I think I'm going to do, Tony, is because not everybody attends every meeting, is I'm going to mention this in the meetings going forward so that everybody gets a chance to sort of, get their thoughts in gear. And again, if you are at all interested, please come and talk to me or email me, and we'll collect the names and assess the level of interest, and after that determine the mechanism by which we distribute them. Sound fair?
Absolutely.
Sound good? Okay. Well, thank you again, Tony, for your efforts on this project. Thank you. Observation reports. Well, I'm going to feel really, really naked up here in a minute. The reason is, what's with you people? Come on, it's not like it's been cloudy for the last 2 months. Holy smokes. Oh, I guess it has been, right? Yeah? Okay. All right. Paul Commission was actually going to come tonight, but as it turns out, Alice, his wife, is not feeling well, so the big guy did the right thing, stayed home, and is providing comfort. So he left me standing at the podium with the only observation reports. So what I'm doing is I'm actually going to roll my observation reports, I have 3 images for you, into a little bit of an update on the Smart Scope, because these 3 images were all taken at the Smart Scope last Saturday. Okay, first one there. All right. Now these aren't the greatest quality. We were shooting these images last Saturday. The moon was full. The sky was hazy. But our intent was there was 3 of us out there: Jim Maxwell, myself, and Wolf. We spent about 6 hours on it. I'm happy to tell you that I think we've got almost all the technical glitches taken care of. Jim has recently replaced the backup batteries for the shutter. All the systems seem to be working. We're getting the. Oh, you are there. I didn't see you. Yeah, knock on wood. There we go. So yeah, I mean, where we're at is we've been exercising the different systems. We've been running them manually. We've been starting to run them with the software that we have there, and things are coming together. So we were able to take images with 2 different types of cameras last Saturday. This was with a planetary camera. Again, the quality is not great because of the sky, but the point is we did have enough of a sky to focus on objects, including Jupiter, including the moon, so we could see if the robotic focuser is working, all those things. So I am tentatively feeling really quite optimistic that we're not far away from bringing this scope online, finally, after many, many years. Our next couple of steps are really to get the software working, which will allow us the remote interface via the internet. We'll have to test that, of course. Jim's going to look at replacing the security cameras that we have in there so that we can monitor the operation of the whole observatory remotely once it is up and running, because we want to make sure that the shutter is closed when it's supposed to be and open when it's supposed to be. So step at a time, but we are getting close, and I'm really cautiously optimistic that maybe even by. Sorry. Yes, we're also going. We're in the process of assembling notes to create a training guide for people to use it and to help us to maintain it. So I'm cautiously optimistic that, and I haven't said this to you, Jim, there, but I'm going to go out on a limb here and say that maybe we can have this thing up and running the way it's supposed to be by late spring, early summer. Okay, so just to give you an idea where we're at. This is an image of Jupiter. We then replaced this is a planetary camera that we used there. We then replaced it with the deep sky camera that we had and shot a picture of Aldebaran. These are just test images that we were taking. And again, as I say, the moon was up and conditions weren't all that great. But it showed us that we could achieve pretty sharp focus with the robotic focuser. And that all the camera systems and the capture systems were working. What I did notice is that the telescope is out of collimation somewhat. It's going to require some tweaking and poking when the weather gets a little bit warmer, but that's a fairly routine process for anybody that's into telescopes there. So I'm crossing my fingers. The last one we took was this one of the heart of the Orion Nebula. And again, with the full moon up, we were limited to what we could do. The collimation led to somewhat larger stars than we would normally get. But you have to remember, this telescope is a 16-inch f10, so it's pretty long focal length. And as a result, it's a very small field of view, quite a magnified degree of imaging that comes through on the sensor there. I saw somebody waving a phone at me. Oh, hi, Gary. Yeah, I wouldn't mind that adaptive optics system. That would be very cool. All we need is a few $1 million. Can we swing that at all? But no, it's coming along well. When we saw the images coming down and all the systems behaving normally, the scope was pointing, it was finding targets, the dome was rotating there. I mean, we still have a few bugs to work out, but I am cautiously optimistic that we're not too far away from bringing this beast online. So cross your fingers and wish us luck with the last remaining tasks that we have. Great. So yeah, stay tuned. All right. Now, we do have actually an extended observation report, not from me, but from John Thompson, who's up on deck next, and who's going to talk about his Australian solar eclipse adventure. So, John, if you're still there, there you are. Come on up. Thank you.
Now, the eclipse in Australia was mid-November, was the November 14th. And I hadn't actually planned to go to this eclipse. I'd been to 4 previous solar eclipses, but I thought that this was only 2 minutes long, and Australia seemed to be a long way to travel to go to a 2-minute eclipse. But on my birthday, which was mid-October, I got this email from the contact from the Easter Island eclipse that I'd been on 2 years earlier, and said, well, if you're interested, there's still an opening. So I thought about it, and I hadn't been to Australia. And turned out I was able to get the time off, so I went for it. Now, the one thing about it, they did predict that being in an equatorial region, it was a lot of rainforest in the area, and the prediction for the weather was about 50% clouds, which meant it was basically a coin toss whether we'd see it or not. As it turned out, the site that I was at was clouded out, mostly. It turned out people about maybe half an hour to the south of us, for the most part, got a good view. I guess in the December meeting, which I wasn't at, there was Shinya Seta. Was he here? He gave a presentation on the eclipse that he had got back earlier than I did. I just returned to Ottawa just a couple of days before the meeting, and I wasn't able to make it. But he gave a presentation, and where he was at just outside of what they call Cairns. It's actually spelled Cairns, but the Australian accent, it comes out Cairns. And the people down in that area were, for the most part, able to get clear skies. My group, I was traveling with a group called Classic Tours Expeditions. It was the same group that I'd been with for Easter Island. And they have, in addition to their main tour guide, they also have a Professor Pasikoff, who is sort of the science leader. And if anybody has a copy of the Peterson's Field Guide to the Stars and Planets, he's the sort of the editor-author of that book. He's also an expert on eclipses. He's been to, I think he says 50, although he counts partials and annulars too in that count. So I'm not quite sure. I guess there's just really no rules on how you count. But anyway, for me, this was my 5th eclipse. And it was the first one that, unfortunately, was a complete wipeout. I was hoping, 50%, maybe we'd get it. But it turned out a couple of days afterwards, down at Port Douglas, which is the town where we're near, I met Glenn Hawley, the national president, that he had led an RASC group from Calgary, and they had set up on the beach outside of Port Douglas, what they call 4 Mile Beach, and they had been clouded out as well. They were just a little to the south of where we were. The group I was with, it turned out they had rented, it was sort of like an executive retreat, a gated community. It was up on almost like a mountaintop. We had to drive up a mile at this steep, climbing, twisty road. And the one thing about that, I realized as soon as we got there that, in a sense, they had violated one of the first rules of eclipses. You want to try to stay mobile So at the last moment, just like Jonathan, he was mentioning that they were able to, using the satellite images, find a sucker hole, aim the ship there and get there. But where we were, unfortunately, we were pretty much stranded up there. So, but as it turned out, what with the way the clouds were moving, it wouldn't have really made a difference, I don't think. That it was impossible to predict exactly where you could get at because the clouds were moving fairly quickly. And in fact, Shinya's pictures, he noted about 5 minutes before totality, a big thick cloud covered the sun and then cleared it within about a minute and a half or 2 minutes of totality. And anyways, I'll get to that after, but I have a feeling that that was the same cloud that actually covered the sun where we were located. So I had 2 tripods and 3 cameras. I was trying to travel fairly lightly. So I had 2 what are called prosumer cameras. They're sort of like an advanced point and shoot. One was a Sony, this one, and one was a Canon. The Sony one, it's able to take external fittings. So I have this is a 2.8 teleconverter on it, and that combined with the full digital zoom was able to make this equivalent to about a 1200 millimeter lens if, scaled to a 35 millimeter format. So I was able to get an image, as you can see, that did fill much of the frame. And then on top of this, I had a visual filter for the partial phases and then pulled that off for what was supposed to be total. So anyways, we can, okay, there it is, because I did put the time and date on the bottom of it. Now this was maybe 35 to 40 minutes before totality. Up until then, we hadn't been doing too badly. It was early morning, and that was one thing that was supposed to be in our favor, that since it was fairly early morning, the heat wouldn't have built up, and they were hoping that all the warm air coming off the rainforest wouldn't have built the clouds up at this point, but fortunately it didn't work out that way. So this was 6:16 in the morning. It was about, the eclipse was about 18 minutes from there. No, I guess it'd be a little more than that. So, okay, we just keep going. Now we're getting worse. The second camera I had was the Canon. It had a wide field, actually a fisheye lens on it, and it had been set up with a special software called the Canon Hack Developers Kit. I don't know if anybody's heard of that, but Canon actually allows their software. It's not quite open source, but you can put this user-developed software into it, which extends its abilities. So the other camera was snapping it away. I was taking an image every 4 seconds. I started it about 10 minutes before totality, and it was snapping an image every 10 seconds, which I'd hoped maybe eventually to try to put into a movie, like a time-lapse, speed it up. Now, what was going on here, this was, as we're nearing totality, the clouds were getting so thick that the auto exposure on the camera was making longer and longer exposures. By this point, I was like taking half-second and eventually 1 second exposures, which, since there's no shutter release on this thing, I was having to just squeeze it. And at that sort of focal length, it was tended to, shake the camera, bump the camera a little bit. That without those clouds, I would have been taking probably like a 500th of a second, something like that. But now we're getting to, fractions of a second, half second, and eventually almost 1 second. So normally, for eclipses like this, you take the filter off maybe 5 to 10 seconds before second contact, but at this point the clouds are getting so thick that I took it off at about maybe 30 seconds before second contact. So now we're getting very close, within a minute. It turned out the very thickest clouds moved in about a minute before totality and stayed there for the entire eclipse, and another 2 minutes beyond that. So the sky didn't actually clear until about 2 minutes after totality was all over. So here, there's the closest I have to the diamond ring effect. That's when just a little sliver of the photosphere is left as the moon covers the sun. And under ideal conditions, you get that. You can see the ring of the inner chromosphere, or corona, and then just this very bright little remaining part of the photosphere, which makes it look like a diamond ring. So there's one Bailey's bead there as well, you can see. And again, the clouds are moving in the way now. I think we're, even with the filter off, it was still something like, 1/10 of a second, something like that. So now this is after the eclipse. So I have a, where's that the video? No, that's not the video. Okay, well, this is after totality. Totality had ended about a minute before that. And so this is about 5 minutes after totality ended. And then I just took a series of partial phases, just showing the sun coming off, or the moon coming off the sun. No sunspots at all. So anyways, out of 5 eclipses now, this is the first one that didn't see totality at all, but it was still an interesting experience. It was different from what I'd seen before. But one thing you'll often notice is that the wildlife, the way they react to the sudden darkening, that birds start to roost. And in the video, you can hear that sort of thing. We can hear the other people. Of the group I was traveling with, there was about almost 20 of us. And then Professor Pasikoff had about 4 or 5 students who were also set up. And they actually had a live feed from one of the local TV stations that was able to get it. I guess they were further to the south and they were able to get the thing. So we could hear people cheering and inside the house where we were setting up outside the house. So we could actually, for some people actually could see that they couldn't see the eclipse, so they just went in the house and watched it on television live. Yeah, I guess we're ready for the video. So this starts about 10 seconds before totality begins. Since the clouds were so dark, I was moving the camera around just to make sure that I had the sun centered because I couldn't see the sun. There it goes. Oh, what happened to the sound?
It should be on.
Oh. No, because there was somebody actually counting down the seconds and then said second contact.
Is that the end of the video?
No, it's still running because you can hear people talking and you hear birds making sounds and things. Is there a volume control in that? Or? Okay.
Not sure about the sound, it's maxed out.
And about 2/3 of the way through, something else you can hear faintly is a helicopter. That one of the features of this executive retreat is it had a helipad built in. So Professor Pasikoff.
Oh.
It's about halfway through now. See, we're a very, very thick, dense cloud. There's no filter at all on my camera. You can't see anything. You can hear my other camera snapping away in the background. It's taking a shot every 4 seconds. At some point, you hear a helicopter. What happened was, about 10 minutes before totality, it was obvious we weren't going to see it. Okay, here it comes.
Yes.
There it comes. So you just see a trace of a photosphere there right in the middle. Guess you couldn't hear the helicopter, but what happened was Professor Pasikoff jumped in the helicopter and went up above the clouds, and he was able to get some pictures, unlike the rest of us who were stuck in the ground. But it turned out he had invited a BBC film crew along to film this, so the BBC paid for half the helicopter, and he had some other sponsor that paid for, another big chunk of it, so that he didn't have to pay for much of it. It's nice to have influence like that. But yeah, I guess that's it. Well, we missed a bit of the sound at the beginning, but I guess that's okay. So anyway, it was a good trip anyway. I was able to see Ayers Rock and Magellanic Clouds, and there was a number of other professors along, so it's an interesting group to travel with too. So So if there's any questions, actually, I have the other camera, the Canon camera, that has the full sky shots that were, being taken every 4 seconds. If anybody wants to take a look at that afterwards, I can maybe show that. Okay. Thanks.
Thanks a lot. Well, better luck for number 6, right, John? Yeah. Mother Nature. Okay, speaking of Mother Nature, last presentation is by me. Yeah, that's right. I've just prepared something for you. Actually, I've been meaning to show this for a while because this is our reality, right? Anybody that does any imaging in Canada knows that the winter time, while we can have clear skies, there haven't been too many this winter, when we do get clear skies, they can be exceptionally clear because in the wintertime we don't have a lot of forest fires in Canada. Forest fires contribute to a lot of dust and particulates certainly in the summer season. It's one of the reasons that we get those nice reddish sunsets sometimes in the summer. But that also means there's a lot of dust in the air. We don't usually get that in the winter. The snowfall tends to keep the forest fires from being a significant factor. Also tends to keep dust on the ground. So when winds blow and howl across the prairies and things like that, not a lot of dust is getting lifted there. So when we do get clear skies, it can be a very rewarding experience. However, that being said, it is Canada after all, and along with our winter comes many challenges for imaging. Well, just as for those of you that just even haul your telescopes out and do observing, visual observing in the winter, you know the challenges that are involved. Things don't work all that well, including digits, especially if you have to take your gloves off and touch cold metal bits. Yeah, I hear some. Yeah. Yeah, I'm sure there's some frostbitten fingers in the crowd. I know I've got a few. So we've got to accommodate. We have two choices. We either have to stay indoors and not do the thing that we love to do, or we've got to say the heck with the conditions. And just like the folks that go out skating on the canal when it's -20, you just have to adapt yourself. So what I wanted to do is just share with you some of the things I've done over the years to facilitate my lust for starlight and how to keep my computer from dying. So next slide, Chris. There. One of the things you can do, obviously, in the winter, if you're imaging, is use a DSLR. Now, DSLRs have come a long way in just a few years. They can provide some excellent imaging. As for those of you that have been in fairly regular attendance, you know that I had an opportunity to borrow a 60DA. This is Canon's new astronomical DSLR. Jason Coley was kind enough to lend me his for a few months, and I certainly made good use of it. And you can, as the next image shows, you can grab some pretty decent images with a DSLR, especially the 60DA. It's really quite nice for well, in a number of ways. I mean, the filter's been modified so that we get a lot more of the hydrogen alpha than a stock DSLR. The vari-angle display screen is very nice, especially when your telescope is pointed up that way and you have to do the limbo to check it out. Not anymore. You just flip the screen and you set it for an angle that's comfortable for your viewing. So very nice features there. I find the batteries on these newer DSLRs are a lot more robust, even in the cold. Like I had no problems with the 60DA running over a couple of different nights on the same battery charge. So quite robust. Even when it started getting cooler, I found the battery didn't deplete very quickly at all. And you know, as a good astro imager, you always have a spare anyway, right? So you don't have to worry about power supplies or anything like that. The DSLR will do the job for you, and so it's made imaging a lot easier, because with the DSLR you don't need a computer, right? You can you just set up your telescope and you mount your DSLR directly and start snapping away and do your other image processing and that obviously afterwards. So it's a much simpler setup than any other type of electronic imaging. But if you do want to do different types of electronic imaging, for instance, high-res stuff of the planets, or as the next one shows, If you want to do narrowband, some of the stuff that I like to do, there you're going to go to a CCD astronomical camera, and that necessitates having a computer, because unlike a DSLR, these cameras don't have a separate display. They just download their information directly into computers. So now what you need is a computer out in the field to capture your data. And that adds a level of complexity, especially in the winter time. So I've been experimenting with electronic imaging over quite a few years. I've had some good successes. I've had some notable failures. On one of my first forays there with electronic imaging, I managed to kill a computer. In fact, I killed it out here in the dome. It froze to death, and never did get it recovered. So what I did is, once that happened, I thought, well, I can't go through computers like I do socks. So I've got to figure out a way to keep my computer warm, especially when it gets into the minus 15, minus 20 degrees. Because certainly when I started getting into this, the very first thing I did, well, actually you can show the next one there, Chris, is, well, there's me with my cup of coffee. I have copious amounts of coffee to keep me warm, and then what I used to do is load up all my imaging computer in the back of the van that you see there. We're talking about desktop units, not talking about laptops. Desktop units powered by deep cycle marine batteries. So quite a bulky rig to set up and transport. And in those early days, computers did have a problem with minus 20. Wimpy things. I guess they were designed somewhere further south where it's warm. Yeah, they didn't hold up well. CRT displays held up quite well, but now we're not talking flat screens. Remember the old days before flat screens, CRTs, like the old TVs? Anyway, yeah, they work really quite well, but they are power hogs, and required, if you're doing field operations, required that you have some sort of robust external power supply. And in my case, deep cycle marine batteries, 2 of the big 140 amp hour jobs there, that would keep me running all night. But yeah, I got my exercise lifting those things. So that's how I started with electronic imaging, but then came the laptop. Now, back then when I started using my first laptop, it's not like today. If you look at a flyer today, you can get a really amazing laptop for a few $100s. I mean, we're talking $300, $400, $500. Gets you way more horsepower than I ever had in the early days. When I started with a laptop, even the low-end laptops were on the order of $2,000. So not really the kind of thing that you want to kill on a regular basis, not unless you have very deep pockets. So after killing my desktop computer, I talked to my engineering friend James McQuaig, and I said, I've got this problem. I need to be able to run these devices out when it's minus 20 or worse, and not have them die on me. So he took his engineering brains away, and the very next observing session, he says, I've got something for you. I said, well, what's that? He says, well, here it is, and there it is. So this is the Run Mark I unit. Yeah, the Run Mark I. He cobbled this together out of styrofoam bits and pieces, took the measurements of my laptop, and cobbled together the Run Mark I. Run is an acronym for RU nuts. He came up with that, I didn't. So when I told him it's minus 20, he says, are you nuts? So he developed the Run Mark I there. And so essentially what I did with this thing is, there it is, throw a laptop in there, and it's got you can see we have a thermometer that we can monitor the temperature, and a little light bulb to keep things warm, but we put the laptop in there and wire it all up there. Then we put a plexiglass sheet in front of the screen there, put a top on that so all the heat doesn't escape, and then cover it up. Really simple, ugly as hell, right? Truly ugly. It is a prototype. It was the Mark I. But you know what? This thing worked, and I still have that computer. So it's been field tested down to, but this particular unit's been field tested down to about minus 23, and it did work. So, but it gave me food for thought. So I used this for a short period of time, and then I got a laptop. Of course, it was bigger, so it didn't fit into the box, and gave me a good excuse to build the Mark II unit. The Mark II unit. So there's the Mark II. And unlike, I learned a bunch of things from the Mark I and applied them to my design. Now this was, I took James's idea of an enclosure like that and I designed and built this one. So the Mark II made use of a Tupperware container. And it had all the bits and pieces in there, including now a wireless keyboard and a wireless mouse, so you didn't have to run wires there. You could have this several feet away from your computer. You could have this whole rig in the back of your van and not worry about it. I also replaced the light bulb with a series of resistive heating lines there, so that there would be enough heat generated to keep the computer, the CPU, warm. So I put the computer in there, put the top on, and you're ready to rock. And the beauty of this is, what I found with this is that I actually probably didn't even need the resistive heating elements. The CPU itself generated enough heat that if you covered it like that, you would keep it warm enough to keep it operating happily. And I used that for quite a while there. That was actually very successful. Then I discovered, well, I didn't discover, but something new came on the scene. Something new came on the scene that had me really excited, because at this point in time, this is several years ago, and I was still running these things off of deep cycle marine batteries out in the wild, because the batteries for the computers themselves back then weren't as robust as they are now. They only lasted for a few hours on a full charge, and typically when I go out imaging, especially in the winter when we have long nights, I'm out for a long night. So typically 6 or 8 hours, sometimes more. Depends how crazy I am, or nuts, as James would say. So while this worked quite nicely, I still needed a very bulky power supply. But then something magic happened. Industry came up with magic, and they delivered to us the netbook. The netbook computer. The netbook is great. I love netbooks for image capture. So I built the Mark III. Oh, this is still the Mark II, just a close-up of the details there, the resistive heating, the power cabling, all that kind of good stuff. But then the Mark III came along, and I actually have this up here. I'll open it up later at the end of the program there. If you're interested at all in coming up and having a look at what I've cobbled together there, feel free. But this is, and I still use this. I developed this a few years ago, and it's just grand. I take this out in the field with me, and I have no problems with it. The Mark III is essentially an aluminized case like that. What I did with it is I found a 17-inch monitor that if I took off, I figured that if I took off the base, would fit very neatly into the lid of that container. It fits perfectly into the lid of that container. So when I deploy it, I've got all the stuff it's all packed in there, all ready to go. What you see here is an inverter, so I can supply electrical power to the screen and to the computer. I deploy things like the mouse. I deploy the keyboard, which is one of those membrane roll-up keyboards that you see in spy movies. They're really good. You can get them for about 20 bucks at Staples. Deploy even an LED light to light up the keyboard. Deploy my USB cables for the cameras and the auto guiders. And then I open up the netbook, which is just nestled in there. The beauty of this setup is I have 2 display screens. I've got the one on the netbook itself, and this particular netbook lets me extend my desktop to a second monitor. So the way I use this system is I run the auto guiding program for my telescope on this particular small display, and then I run the image capturing on the larger display. And these netbooks, they're small, but they're deceptive. They've got more than enough horsepower to allow you to run both of these operations simultaneously. So you're downloading good-sized files from your CCD camera, and you're running an active auto-guiding program off the same CPU, and it doesn't seem to stress them at all. The beauty of it is, too, that the current generation of netbooks have really good batteries in them. We're talking like 6 to 8 hours on some of these things, and I find that they live up to their specs. I can run a full imaging session on just the battery pack that's in that computer. Now, if I want to run the monitor, even these monitors, because they're flat screens, draw a lot less power than the CRT screens used to draw. This combined system only draws 40 watts for the computer and for the monitor itself. So I no longer have to schlep around these 80-pound deep cycle marine batteries. Just the Canadian Tire power packs that you can buy, the booster packs there, 18 amp hours, more than enough to run a field session at night, and they're very much more portable than the deep cycle marine batteries. I no longer have a van, so you see I had to adjust my way of doing things. But all this stuff is so compact now that it easily fits into a much smaller vehicle. And as I say, I still use this system today. It's quite nice. If it's really, really cold out, what I can do is, I'll just roll that back. What I can do is, because I have the auto guiding system working here, I can just close the lid of that computer. The auto guider will keep on guiding, and I can put just a small cover over the top of it. Again, that helps to keep the heat of the CPU in, and it keeps that entire compartment very, very warm. I field tested this out down to about -26, -27 Celsius, and there's no problem. And with the way that the monitor itself is recessed into the lid of that case, it seems to retain a lot of its own heat, and I haven't had any glitches or hiccups with this system even under those conditions. So this seems to work quite well. It seems to work quite well. And one last addition, suggested by my friend Glenn, who couldn't be here. Glenn Ledrew told me on several occasions that I have to set up my imaging equipment at sort of the edge of, if we're observing with a group of people, at the edge of the group there, because I tend to illuminate the area, let's say, with my display screens there. So what I did is I modified this to put a cloth cover over the top of it, and so that once I've got my imaging set up, everything is running, I just put the cover down on it, the whole thing is covered up, heat's all captured, camera's guiding, or taking pictures on the auto guider's happy. So and I don't tick off my observing buddies there. So that works quite well, and as I say, I still use it. Now the Mark IV, there is a Mark IV. This is the Mark III. The Mark IV, just again another close-up of the guts there. As I say, you're welcome to come up and have a look at it later if you're interested. The Mark IV came along just recently. I was at Starfest 2 years ago, and one of the vendors had this really interesting looking device, and I thought, what the heck is that? It's a lap dome. A lap dome. You gotta like that. I've got, in fact, it is. Funny you should mention that. Looks like a doghouse. The lap dome is awesome because with this, you perform much the same function. The netbook computer easily fits inside that. There's two sizes. This is the large size. The small size will accommodate a netbook. The large size will accommodate a full-size notebook computer. It's rather well insulated. I put an extra piece of foam down at the bottom of it so that the CPU can sit on that. And again, it's not bringing up any cold from wherever it's sitting on. Use a wireless mouse, and bada boo, bada bing. It's wonderful. It's completely self-contained. As I say, the batteries run for hours, and so I can just take out the lap dome with a netbook computer, and now I'm carrying something in one hand that used to take me a van to transport. So much more user friendly for imaging in winter conditions, and in fact all year round, because the other advantage of using something like the lap dome is even when you're imaging in the spring or in the fall or in the summer when it gets really dewy, that enclosure keeps all the dew off your computer screen and controls there. So it helps keep the computer healthy, which is rather nice. So yeah, it fits in there quite nicely. With a wireless mouse, you can control it again from several feet away. As I say, there's two sizes of it. The small and the large. Before I just bought the large recently, but funny you should mention the doghouse, because the time between when I bought this one and this one, I happened to be in a dollar store, and guess what? I saw a pet house. Somebody called it there. It was $4, and I thought, this looks an awful lot like a lap dome without all the insulation. So I bought one. I could not buy one, right? And so what I did is I bought the doghouse for $4, and I used the thermal insulating blankets, the emergency blankets. I just cut those to size and glued them onto the side panels of the doghouse to keep the heat of the computer inside. And then on the outside of that metal, I again glued some of that very small bubble bubble pack stuff. Again, you're trying to build a bit of an air layer there to keep the heat in, and it works. It cost me, I think, a total of $8 to build that, and it protects my investment. So there's the fleet as it stands right now. There's the fleet, the Mark IV fleet. Yeah, A, B, and C. So highly recommended, especially for winter, but really any time that if you're going to be out there with a netbook computer or other electronics that you want to protect, these things are lovely, and they're not very expensive. This one here I think cost me $30. This one here cost me $50, and as I mentioned, this one cost me $8. So depends on your pocketbook, and if you like to tinker with things, and I find it works quite well. Although the opening isn't big enough really to fit a full-size netbook or notebook in there unless you really jam it in. But yeah, the big size accommodates pretty much every notebook that I've seen. So that's the Mark IV. Almost the end of the story. There is a Mark V. Mark V is currently under construction. The Mark V isn't quite as portable as any of these others, but my lady and I moved out to this wonderful dark sky area about 20 kilometers west of Almont back in March. We have really, really dark skies. We're in the green zone, bordering on the blue zone out there. So when the sky is clear, we get some very, very clear nights. And so I bit the bullet, and I've ordered a Sky Shed pod. And I ordered this back in the late summer. It should have been here in November. There was a delay at the factory. I only got it 2 weeks ago. So I haven't assembled it yet. I've built the framework for it. Everything else is now ready to go, except that I need warmer temperatures. Plastic doesn't really assemble all that well at -20, so I may have to wait a bit. But ultimately, that's what's going to sit on the platform there. So again, not very portable, but it will shelter the telescope. So that's the Mark V. Stay tuned. I'll show you my pictures once it's built there. So that's where I'm at with winter observing in Canada. And yeah, I wanted to dedicate this presentation to the compact 486-33 that froze to death out in the dome out there many years ago, so that future generations of computers could live on, be warm, and continue imaging. So rest in pieces, and thanks for listening. All right.
Paul, I have a question.
Yes.
Are you planning on making a Mac version of this?
A Mac version? I don't know. My lady just got an iPod, and I had a hell of a time trying to get it to talk to her PC, so I don't know. That's exactly what it's intended for. Yeah, it's made for people that use computers for various applications out in open environments. If you're interested in getting one, where I bought this was KW Telescope down in Kitchener, and they've got a website there. You can order it; they'll ship it to you. So yeah, and they're very reasonably priced, and they're lovely. I highly recommend them. I've been out imaging on some pretty dewy nights there, and the skin of this thing is like dripping, and inside, just with the heat generated by the CPU itself, bone dry inside, no issues at all. So yeah. Sorry?
How much is it run for?
The large ones go for about $50. The small ones go for about $30, and the doghouse is $8. Some assembly required. All right. Any others? No? Okay. Yes?
Do you have any techniques or tricks for dealing with stiff wiring in the boat?
Stiff wiring. Yeah, that's a real bone of contention. There's not really much you can do except that there are different types of cabling that are made for the colder environments. For instance, I'll give you an example. The wiring that's used in a lot of the dew heaters that you wrap around your telescope there is created to be pliable, very flexible, even under extreme conditions. Other wiring, just it's not a happy thing. I notice with things like Ethernet cables and USB cables, they just don't really like the cold at all. So the only thing that I can recommend is what I do with them is that I often set up my cabling last. I'll keep the cabling in the warm car to keep it pliable, and then when I do set it up, I set it up quickly, roll it out to the full length, because you know that if you're setting up and it's minus 15 or minus 20, you know, within 5 or 10 minutes, that cable is going to be stiff. So you want to deploy it quickly, get it connected, and have it the way you're going to run it for the rest of the evening. But yeah, failing that, the only thing you can do is seek out cable grades that are made for more extreme environmental use. So, unless you want to heat your cables, but all right. Anyway, just in closing, just a few notes. I'd like to extend again an invitation to anybody that has something that they would like to talk about, things they found, like Jonathan's report on the state of Canadian science, or just me sharing some observing techniques and things that I've used. We really welcome anything that that you think would be of benefit or of interest to the members that's related to astronomy and space topics generally. So if you do want to, if you've got something in mind you'd like to prepare a presentation, please contact myself or Chris. My email address is up there. You can contact us anytime. If you need help putting it together, we can provide that as well. We have templates that we can use in PowerPoint, and we can assemble it. We can help you assemble your work into something that's usable. Okay, and we do have guidelines for the presenter on the website. So we welcome suggestions. The more people with different perspectives, I think, the better enriched we all are for that. All right, Sylvie, are you there?
Yeah.
There you are. Oh, there you are. I'm being blinded. Come on up, Sylvie. Sylvie has something very important, especially for the guys in the crowd. So listen up.
Actually, that's only one of the things I have. I have a whole list of them here.
There we go.
We'll just leave it up there. That's fine. Okay, so first, the museum is hosting a stargazing night on February 14th, and I guess somebody called it Cosmic Love. It's not my idea, but I guess that's the title. Brian will be operating the telescope here, and so we want to promote that event. Do we have another slide for me, or is that the slide? That's the slide, okay. But on the RASC side, we've been asked to have some volunteers come out and have their telescope for people to see through. So if somebody would like to come out on February 14th and come and do that, well, we need people, but we also would need somebody to coordinate the whole thing with Melanie. That's one of the outreach events that we have coming up. We have requests for many other things, so I will just name them briefly, and come and see me after the meeting if you're interested of getting involved. We have been approached by the Canadian Space Society. They're organizing their next space summit. It will be in Ottawa next November, and they are asking to see if we would like to collaborate with them into a big outreach day, which would probably be very much similar to the Science Fun Fest that we get involved with every fall. We have school requests in the works as well. We have a group that's interested in having somebody coming in for quite a number of weeks, once a week for about an hour after school. We have a event happening actually this coming week. That's a bit of a last minute thing. A group of brownies out west, very far west, past Carp, actually just before and prior in Kinburn, that is interested of having somebody going out there to talk to the brownies. I'm going, but if somebody wants to come and help, that would be appreciated. We have other school outreach in French, unfortunately, but if somebody is interested in helping and can speak French, all the merrier. And the last one on the list, again by the Canadian Space Society, they are going again this year to have a URI's night at the Aviation Museum. I hear it's on April 12th, and they would really love for us to have a outreach table out there to show our goodies of astronomy. So if anybody's interested in any of those, come and see me right here after the meeting. Catch me for the next half hour, or else I'll see you at Kelsey's.
Perfect. Thank you, Sylvie. Awesome. Did you design that?
Absolutely not.
No, eh?
No.
Nobody told me I was doing cosmic love.
No, I
I'll play my
You probably designed this, didn't you, Brian? Yeah? It's nice, actually. All right.
Actually, if I can
It
just
looks
pitch
like
in,
a heart,
if you
right?
are interested in helping out on the February 14th date, you should contact me.
Oh,
And of
you
course,
can-
you have to be have a security clearance at the museum. Many of us do, and it's easy to obtain if you don't have one yet. Just contact me if you're willing to help.
Oh, there we have a coordinator.
Always.
Awesome. Thank you, Chris. All right, and just in closing, Estelle is here and the library will be open. Pick of the month, The Sun's Heartbeat, and other stories from the life of the star that powers our planet. Absolutely. Good stuff. Post-meeting, we will have, Al Scott is here. I don't know if he'll be talking about the Lone Library at all. Are Art and Ann here? I didn't get a chance to get out. Great. Okay, so Art and Ann are out serving their usual goodies, and you can talk to Art about membership info and membership cards. Talk to us about Sky Intel and astronomy renewals, because I don't think Stephen is here, right? The rest of the museum is closed, and we will have our after-hours meeting over at Kelsey's for those who find themselves getting very thirsty in the dry air of this auditorium. So that is available. We had 109 folks tonight. Thanks again for everybody that contributed to putting the presentation together, and to the museum for hosting us. Again, comments and complaints, yay. Again, I encourage you, if you do have some interest in the pillars that we talked about, that Tony mentioned, please give me a shout there, because I really like to assess the level of interest there so that we can decide how we're going to disperse these, okay? So definitely give me a shout, paul.cloninger@yahoo.ca. And our next meeting is on March the 1st, here again at 8 o'clock. So we hope to see you all here, and hope you have a great month, and cross the fingers, hope we get some clear skies as well. So we'll see you next month. Take care.